In this video, we will investigate 3 types of exoplanet detection techniques and study the population of exoplanets that have been discovered. Right now, we're moving through the solar neighborhood of nearby stars, and the first simulation will be to visit the planetary system around the star 51 Pegasus, and this is a solar-type star that is only 50 light years from the Sun. This animation is indicating the orbit of the planet that you're seeing now moving around the star 51 Peg. And this planet is a giant planet, even larger than Jupiter in our own solar system. And the view has been magnified by the size of the planet has been magnified by a factor of 2 just to make it more visible. Next, we'll see how the planet was discovered. The cartoon below the star shows the spectrum of the star, and you see dark lines from atoms absorbing light in the atmosphere of the star. Because of the tug of the planet on the star, just as the star is tugging gravitationally on the planet, you see the motion of those spectral lines, and that indirect detection technique is how this exoplanet was discovered. This is called the radial velocity technique. In our next system that we will investigate, this will be a planet that was discovered by a different technique through the transit technique. So next we'll be visiting the star HD 209458, which is again a solar type star, and it's about 150 light years from the Sun. In this case, we'll see the orbit of the planet around the star. So we'll have a simulation of again, a giant planet like Jupiter orbiting around the solar type star, and you see as the planet moves in front of the star, there's a shadow. And that shadow is essential to how these population of exoplanets are discovered through the transit technique. So again, we'll see the planet moving in front of the star, and you see that shadow. Next, we'll add a cartoon that gives an indication of how astronomers detect these planets. You'll see a cartoon come up with what is called the light curve of the system. So this is measured by measuring the brightness of the star as a function of time, and you notice that as the planet crosses in front of the star, then the light curve will dip. So here again we see the planet moving closer and about to cross the star, and there you see the dip of the light curve as that happens. And those regular dips of planets crossing in front of the star are how planets are discovered through the transit technique. So next we will be moving to a simulation of a system that was detected by a third technique. In this case, the planets are actually directly imaged. What you see first is a cartoon of an example image of a star seen through a telescope. And you see a lot of bright light surrounding the point of the star. And so next you see a more compact what is called the halo, that bright region around the star, making it easier to identify planets in that halo region. And finally, if a coronagraph is used to block the light of the star, then planets become visible. Those are the smaller points of light around the star. And we'll see actual images like that soon. So first we go to a cartoon that shows the 51 Aries system. This is a star that's about 100 light years from the Sun. And you see it has both rings of dust, and as we zoom in, we'll reach the region where a planet was actually imaged. You see that as the red giant planet imaged in the system between the two belts. And now you're seeing the actual astronomical images of the glow of that young Jupiter-like planet being imaged around the star. Next, we'll take a second look at the population of nearby stars in the solar neighborhood. And in this case, we will identify stars that have planets with circles around them. And you can see that the field of stars around the Sun is populated by many systems that are known to have exoplanets. Now we're taking a more distant view, and you see the region farther from the Sun. You see a galactic view, and that extension of the green points are showing detections of exoplanets based on a NASA satellite that stared at a particular direction in space. And so you can see that there are many more exoplanet systems to be discovered as more and more of the galaxy is explored.